Okay, this section is arithmetic sequences. I'm going to try to go through it fairly quickly because there's a lot in it. It's a lot of examples, and so I'd like to try to keep the video fairly short. So if you need to, make sure you go back, watch it again. Our goal for this one is to identify and extend patterns and represent arithmetic sequences using function notation. Okay. So what we want you to know from this is that a sequence is an ordered list of numbers that often form a pattern, and that each number is called a term. So make sure that you write that down. We want you to describe a pattern in each sequence and then find out what are the next two terms. So the first thing that's usually a good idea is to check to see if we are adding or subtracting the same number each time. So between 5 and 8, what would be between 5 and 8? That would be add 3. Is it the same from 8 to 11? Yep, add 3. 11 to 14, add 3. Okay, so describe that pattern in each sequence. You add 3 to the previous number. Okay, how about this one? Again, try to find out, is there something that's being added or subtracted? You add 2.5. Here to go from 5 to 10, you add 5. And here from 10 to 20, you add 10. So that's not the same. That doesn't work. So we have to look for something else. Is there possibly something that is being multiplied or divided by? So if you can't get the first one or the middle one, you can always sneak to the end too. How do you get from 10 to 20? What can you multiply by? Well, that's multiplying by 2. Is it the same from 5 to 10? Yes, multiply by 2. And does that still work going from 2.5 to 5? Yeah, that's multiply by 2. So describe that pattern. Multiply a number by 2 to get the next number. And then they wanted us to get the next two terms. So if we keep adding 3, we go 17, 20. If we keep multiplying by 2, we'll get 40 and 80. Okay? Describe a pattern in each sequence. What are the next two terms of each sequence? Okay, again, 5, 11, 17, and 23. So between 5, 11, between 5, 11, 17, and 23, is there anything that we add or subtract each time? Yes, we add 6 there, add 6 there, and add 6 there. So describe the pattern. Add 6 to get the next number. How about part B? So that was A. Part B. We're going down. So how about subtracting? Minus 200 to get from 400 to 200. To get from 200 to 100, we have to minus 100. So that doesn't work. Okay? So let's try something else. Is there any other way to get from 400 to 200 not subtracting? And again, if you don't notice that it's dividing by 2, you could always see, how about to get from 200 to 100? But this is divide by 2. From 200 to 100, divide by 2. To get from 100 to 50, divide by 2. So divide by 2 to get the next number. So the next numbers, the next two numbers here, we're adding 6. That's 29 and 35. Here it's 25 and 12.5. Real quick, if you want to take a look at these, C and D, go ahead and pause the video right now and try to do those yourself. For C, the answer is we are multiplying by -2 to get next number. And for this one, we are adding 4 to get the next number. Your next numbers here, this would be 32 and then negative 64. Here, it would be 1 and then 5. So an arithmetic sequence is when the difference between the consecutive terms is constant. Okay? This difference is called the common difference. So make sure that you write that down. So we're wondering, is the sequence arithmetic? So is the difference between these always the same? So between 8, 15, 22, and 30. Difference between 8 and 15, plus 7. 15 and 22, plus 7. 22 and 30, plus 8. So is this an arithmetic sequence? Your answer is no. How about we try part B? 7, 9, 11, 13. From here, it's plus 2. Here, plus 2. Here, plus 2. Is it arithmetic? Yes. If it is, what is the common difference? 2. Now, if it's a negative 2, make sure you put negative. If it's not, we assume it's positive. Okay? If you want to try part C and D, go ahead and pause the video. Okay, the difference between part C, this is minus 6 from 4 to 2, minus 6 from negative 2 to negative 8, minus 6. So yes, it is arithmetic. The common difference is negative 6. The difference between 2 and negative 2 is negative 4. From negative 2 to 2, it's positive 4, and then back to negative 4. So that is not arithmetic. So a sequence is a function whose domain is natural numbers and whose outputs are the terms of the sequence. So sequence is like a pattern. Okay? And we can write a sequence using what's called a recursive formula. A recursive formula is a function rule that relates each term of a sequence after the first one to the ones below it. So what we're saying is the only way that you can get the next number is by using the previous one. Okay? So here are your terms. 7, 11, 15, and 19. There's no x, there's no y, there's nothing like we can say, hey, it's just y equals 2x or anything like that. We have to know the first term in order to get the second term. So if we look at that, the first term is 7. The next term, a2, is a1 plus 4. That's how you get 11. And then 11 would be the value for a2, so when you come here, a2 would now be 11 plus 4, that's how you got 15. 15 becomes the previous term, plus 4 is 19, and so on and so on. So the way that you can write that is a of n minus 1. So this isn't a times n, a times negative 1. That's not what it is. It means a, and then the number is whatever n is. So if we're looking for the fourth term, this would be 4 minus 1, so that would be the third term plus 4. And then you have to also state where a sub 1 starts. Write a recursive formula for this sequence. Okay? So what we want to do is we want to start off by saying a sub 1 equals 70. That's where you should start. And then you should write a sub 2 was the previous one, a sub 1. And what did we do? We added 7. That's how we got 77. A sub 3 was a sub 2 plus 7. So that was 77 plus 7. That's how we got 84. A sub 4 was a sub 3 plus 7. And that's how we got 91. So what is the value of the eighth term? Well, we need to write this. How about a sub n? A sub n would be, in keeping with this sequence, take the previous 4 minus 1 is 3, so n minus 1, and add 7. So now if we want to know what's a sub 8, we say we need a sub 8 minus 1 plus 7. So this would be whatever a sub 7 is. But we don't know what a sub 7 is. So we would have had to continue this. So you have to continue. Okay? So over here, a sub 5 would have been 91. Oops, I'm sorry, a sub 4, which is 91, plus 7, which is 98. A sub 6 would be 98 plus 7, which is 105. A sub 7 is 105 plus 7, which means that here a sub 7 is 112 plus 7. Your answer is 119. Okay. There's actually a formula that you can use. So this is the explicit formula for an arithmetic sequence. The nth term of an arithmetic sequence, with the first term being a sub 1 and a common difference of d, is this. You take the first term plus term number minus 1 times d. So let's see that in action. Okay. An online auction works as shown below. Okay. The first bid was 200, the second bid was 210, third bid 220, and 230, and so on. So what we have to do is we want to find our common difference. How do we get from 200 to 210? We add 10. 210 to 220, add 10. 220 to 230, add 10. Okay? So now if we use this previous formula, okay, we say, what was a sub 1? Okay, what was a sub 1? What was the first bid? The first bid was 200. Okay. Plus term number. So what's our term number? Do we know our term number? Do we know what one we want to use? No, we want to write it explicitly, meaning we want to write it for the in general. So we're going to leave this n minus 1, and then we're going to take it times our common difference, which is 10. Now what you do is you can go ahead and distribute this. So you would get 200 plus 10n minus 10, and you can combine like terms. In which case, you would get a sub n equals 200 minus 10. It's 190, but I'm going to flip these, so I'm going to write 10n minus 190. Sorry about the pause. I knew I did something wrong, and I couldn't figure out what I did wrong right now. It's not minus 190. It's 200 minus 10 is positive 190. I was stuck for a second. I couldn't figure out why. So now, if it asked what's the 12th bid, well, we can just take in and plug 12 in there and go 10 times 12 plus 190. 10 times 12 is 120 plus 190. And so your 12th bid, if it goes up by $10 each time, would come out to be $310.